Ladies and gentlemen, now, we will start our fifth lecture of the analyze phase. During the lecture, the following topics will be covered: 1. Way Anova. 2. Way Anova. ANOVA, analysis of variance. We do it to compare 3 or more groups of population to each other, to see if any of the group means is statistically different from the others. An ANOVA is used to analyze the relationships between several categorical inputs, KPIV, and one continuous output, KPOV. Use an analyze to confirm the impact of variables. Use an improve to help select the best option from several alternatives. Suppose in the manufacturing process, we want to compare and check which are the most reliable procedures, materials, etc. We can use the ANOVA test to compare different suppliers and select the best available. In the statistical world, inputs are sometimes referred to as factors. Samples may be drawn from several different sources or under several different circumstances. These are referred to as levels. For example, we might want to compare on-time delivery performance at 3 different facilities, A, B, and C. Facility is considered to be a factor in the ANOVA, and A, B, and C are the levels. To tell whether the 3 or more options are statistically different, ANOVA looks at 3 sources of variability: total variability among all observations, between, variation between subgroup means, or factor, within, random, chance, variation within each subgroup, noise, or statistical error. In one way ANOVA, we look at how different levels of a single factor affect a response variable. In two-way ANOVA, we examine how different levels of 2 factors and the interaction between those 2 factors affect a response variable. Now, we will do one-way ANOVA. We have k number of samples. The k samples are being tested. The null hypothesis will be in the form of H0, mu1, equal to, mu2, equal to, other mu's, until mu k. The alternative hypothesis will be H1, at least one sample mean is different from the others. The null hypothesis is not rejected if the means of all the samples are equal, and it is rejected if at least one mean is different from the rest. The differences between sample means can be traced to 2 sources: the variations due to actual differences between the sample means, and the variations within the sample. ANOVA examines the variances of the samples to determine if there is a difference between their means. To calculate the one-way ANOVA, follow the steps. 1. Calculate the sum of squares of the deviations between samples. It measures how far each sample mean is from the mean of all the samples. It is noted as SST and is obtained from the following formula. 2. Calculate the sum of squares of the deviations within samples. It measures how far each observation within a sample deviates from its mean. It is also called the sum of squares for error, SSE, and it is obtained from the following formula. 3. Calculate the total sum of squares, which is the sum of squares for treatment, SST, and the sum of squares for error, SSE. 4. Calculate the mean square for sample, MST, will be SST divided by DF treatment, which is equal to k minus 1. 5. The mean square for error, MSE, will be SSE divided by DF error, which is equal to n minus k. 6. The F statistic is obtained from the ratio of the mean square for samples to the mean square for error. F is equal to MST divided by MSE. If the variation between samples is large, the mean square for samples will be large. If the variation within samples is large, the mean square for error will be large. The calculated F statistic will be large if the mean square for samples is large, and it will be small if the mean square of error is large. The decision to reject the null hypothesis is made by comparing the calculated F statistic to the critical F statistic found in the F table. The null hypothesis is rejected if the calculated F statistic is greater than the critical F statistic. Compare the p-value with alpha level. If the p-value is smaller than the alpha level, the null hypothesis is rejected, otherwise, we fail to reject it. Here is a table includes all the calculations of Way Anova for reference. To calculate the critical F statistic using F table, there are 4 tables. For 4 alpha level, alpha is equal to 0.10, n, alpha is equal to 0.05, n, alpha is equal to 0.025, n, alpha is equal to 0.01. In most cases, we will use alpha equal to 0.05 table, which is shown. The F distribution tables are ready for download in the resources. Using the available 2 degree of freedoms, the treatment and error, you can find the critical F statistics and compare it with the calculated F statistics. To create a Way Anova in Excel using Sigma Excel, click Sigma Excel, then Analyze Statistical Tools, then click Way Anova and Means Matrix. Ensure that the entire data table is selected. If not, check Use Entire Data Table. Select Numeric Data Variables Y. Click OK. To create a Way Anova using Minitab, click Stat, then Anova, then click Way. Choose the responses and click OK. Now, we will make an exercise for Way Anova. An operations manager is comparing the productivity per hour of 4 machines. He takes samples of units produced per hour from each machine and tabulates them in table. Can we say that the productivity of the 3 machines are equal with a confidence level of 95%? Please pause the lecture and solve the exercise. Here is the result of Way Anova using Sigma Excel. The table shows the following: sum of square, SST, and SSE, degree of freedom of treatment and of error, mean square, MST, and MSE, calculated F statistics, and p-value. The report also includes the mean confidence interval plot and an abnormal one-way plot. DF treatment is equal to K-1, which in our case is equal to 4-1, equal to 3. DF error equal to N-K, which equal to 28-4, equal to 24. Using F table of alpha, which equal to 0.05, the critical F statistic, F of 0.05, and 3, and 24, is equal to 3.0088. The null hypothesis is rejected if the calculated F statistic is greater than the critical F statistic. Calculated F statistic from the Sigma Excel results in 3.988. The calculated F statistic is greater than the critical F statistic. Also, the p-value equal to 0.0194, which is less than alpha, which is equal to 0.05. So, the null hypothesis is rejected. When making deep analysis, sample number 2 has a higher deviation with lower mean value. To Way Anova, examine the effect and interaction of two independent, discrete factors on continuous, dependent output variables. Analogous to the 1 factorial model, the total deviation is the addition of the squared sums of the individual factors. The squared sum of the factor interactions and the squared sum of the errors spread within the factors. Total sum of the squares equal to sum of the squares from factor A plus sum of the squares from factor B plus sum of the squares from interaction between factors A and B plus sum of the squares from the error. If the sum of the squares from the factors and the factor interactions is significantly greater than the spread within the factor, then a difference exists and the null hypotheses can be rejected. To create a two-way ANOVA in Excel using Sigma XL, click Sigma XL, then Analyze Statistical Tools, then click Two-way ANOVA. Ensure that the entire data table is selected. If not, check Use Entire Data Table. Select Numeric Data Variables Y, select Group Category Factor X1, and select Group Category Factor X2. Click OK. Click OK again. The results are shown. Scroll down to view the main effects, with confidence intervals and interaction plots. Note that the mean values shown are fitted, predicted, means not data means. To perform a two-way ANOVA in Minitab, use Stat, then click ANOVA, then click General Linear Model, then Fit, General Linear Model. In Responses, enter the response heading. In Factors, enter the factors headings. Click Model. In Factors and Covariates, select both factors. To the right of Interactions through order, choose 2, and click Add. Click OK in each dialog box. In these results, you can conclude the following. Based on the p-values of each factor, and the p-value of the interaction effect between the two factors, and compare them with the significance level of 0.05. Or based on the f-value of each factor, and the f-value of the interaction effect between the two factors, and compare them with the critical f. You will reject, or fail to reject the null hypothesis. However, please note that you cannot interpret the main effects without considering the interaction effect. If the p-value in the ANOVA table indicates a statistically significant main effect or interaction effect, use the means table to understand group differences. For main effects, the table displays the groups within each factor and their fitted means. For interaction effects, the table displays all possible combinations of groups across both factors. Use the residuals versus fits plot to verify the assumption that the residuals are randomly distributed and have constant variance. Ideally, the points should fall randomly on both sides of 0, with no recognizable patterns in the points. Use the residuals versus order plot to verify the assumption that the residuals are independent from one another. Independent residuals show no trends or patterns when displayed in time order. Use the normal probability plot of residuals to verify the assumption that the residuals are normally distributed. The normal probability plot of the residuals should approximately follow a straight line. Tables show how to set up the data for two categories of patients treated with three different drugs. Then, if you're just interested in the single-factor drugs, select and run a single factor on the three drug columns. What if you have two populations of patients, male and female, and three different kinds of medications, and you want to evaluate the effectiveness of the drugs and the type of patient? You might run a study with two or more applications. More than one patient in the category receives the same drug. Please pause the lecture and solve the exercise using Sigma Excel or Minitab. 1 Way Anova results for drug data. Calculated F statistic is equal to 1.343, less than critical F statistic, which is equal to 3.68. The null hypothesis is not rejected because the calculated F statistic is smaller than the critical F statistic. Means are the same for the three drugs. From 1 Way Anova for the three drugs, the null hypothesis is not rejected because the p-value equal to 0.2906 is greater than alpha, which is equal to 0.05. Means are the same for the three drugs. The situation will be the same if you take into analysis the male and female categories of patients. Calculated F statistic is equal to 8.151, which is greater than the critical F statistic, which is equal to 3.885. The null hypothesis is rejected because the calculated F statistic is greater than the critical F statistic. Means are not the same for the three drugs on the two categories. The p-value for the interaction of the drugs and patients is less than 0.05, so the effectiveness of three drugs is not the same for the two categories of patient. This result is very clear in the plot. In an automobile industry, three quality inspectors, A, B, and C, measure the braking strength of car seat fabric, and the management wants to test for a difference between the measurements by comparing means. Perform the Anova test in order to accept or reject the null hypothesis. Please perform activity and send the output by email for assessment. Please download the PDF file, 1 Way Anova, case study and perform the required activity. Please send the outputs by email for assessment. Please download from the resources the instructional videos for Anova using Sigma Excel and Minitab. Anova sigmaexcel.mp4, Anova minitab.mp4. Thank you, and see you in the next lecture of Analyze phase.